Hello students, now let's see the example of pseudocode for designing the algorithm. This example is calculating the area of rectangle where three variables are passing as an argument. Suppose if we don't want to pass the area argument and we want to return the value of the area from this function. So already we have discussed that the function algorithm should not return the value, we should not mention the value, but it can return what the particular value. So in this way we can say that return area is nothing but what the our last statement. So the next is example of the selection statement, that is a conditional control. So here we will see the example of finding the greatest number among the three numbers. So the algorithm is the first one and the name of the algorithm is greatest, and I am passing the three arguments along with the result. If you if you don't want to pass the result, you can return the result from this algorithm. So here what we will do is we will use the read instruction from the to take the input from the user, and after that we will see that whether the number 1 is greater than the number 2 and the 3, then we will assign the number 1 to the result. Otherwise, what we will do is we will see that number 2 is a greater than the 1 or the 3, then that time the result is nothing but what the number 2. Else, what we can do is the result is what the 3. So in this way, what we will do is we will write the output by using the write statement, write result. Otherwise, you can use the return statement which will return the value. So the next example is what the repetition statement or iteration statement. Here we are going to find out the largest value among the 10 numbers. So we will see that A is the array of the n element, and there is one variable called as a large which is going to held the largest element among the array. So you can see this algorithm. Otherwise, you can return the value largest element from this algorithm. That time you require only the two parameters. So what we will do is the first one is what the read instruction. So we will read the elements of the array. We will by using the for statement. So we will read the individual array elements. After that we will set the large variable to the first, and after that we will iterate from first to the n minus 1, and we will see that whether the a of I is greater than large. If any value is greater than the large, we will reinitialize the large variable with that a of I, and we will write the large or what the return the large. So for example, if I have the 5 and after that what the 3 and what the 2, then what the 8 and then what the 1. So this is 1. So initially the large is what the initialized to the 5, and after that we will retrieve from I is equal to 1 to I n minus 1, and we will see that the 5 is greater than a of I. A of I is greater than the 5. If it is not, we will not exchange or we will not set the new value for I. When the I is reaching to what the 3, my large is what the 5 and A of I is 8, and A of I is greater than the large. This condition true, so that time the large is going to initialize with the 8, and after that again the 1 is going to be compared with the 8. This condition false, and we will reach to this statement where we will return the large or write the large. So the next example is we have to write the algorithm to calculate the sum of only even numbers which are present in the given list, and also count the even number present in the list. So we have to do the addition as well as how many elements are there, even elements are there. We have to find it out. So we will pass the algorithm, and the name of algorithm is count even, and we will pass the corresponding parameters to the algorithm. And after that we will initialize the variable sum and e count equal to 0. We will read the n, and after that we will read the array elements. and after that from 0 to the n minus 1 we will retrieve one element, and we will see that mod of 2 is 0, means it is even. We will write it, we will increment the counter, and we will add that element to the sum variable. So in this way, after the completion of the for, we will write the sum as well as what the count of the even numbers. So here the variable sum is what the acting as a accumulator for the 10 numbers, and e count is acting as a counting of the even numbers. So the same thing what you can do is you can do for the odd also. So you can practice that. You can write a pseudocode for finding out the number of the odd elements. So the next tool that we can use to represent the algorithm is flowchart. So the flowchart is nothing but what the graphical representation, where you are carrying the one by one step to accomplish a task. Graphically depict the logical steps to carry out a task and show how the steps are related to each other. So for the flowchart we have to use some symbols, and these symbols had the specific meaning. So the first symbol is what the flow line, which is going to act as the connector between the symbols, and it will also indicate the flow of logic. So the next is what the terminal, which is going to use, this symbol is going to use for start and the end. Whenever we want to do some input and output operation, okay, for reading and displaying, so we have to describe that data in this particular symbol, rhombus symbol. Whenever we will use the rectangle, so whenever we are doing some kind of the arithmetic or data manipulation operation, so that particular statement or the pseudocode we have to write inside this rectangle symbol, that is a processing. So the next is decision symbol, where we want to do some comparisons between the variables, and we want to change the flow of control. The path is going to decide whether the value of that particular conditional statement is true or not true. So depending on that, every decision box has the two paths, that is what the yes, and second is what the no. So the next one is what the connector. So suppose you have the big flowchart. So in one page you have completed it, in second page you want to continue it, so you can use the connector to join the flow lines. So whenever we want to do the sequence statements, so in this way we can have one box where I can initialize the statement A, B or C, or in the single box I can write statement A, statement B and the statement C. So for example, we want to calculate we want to read the three numbers and calculate the total of the three numbers. So we will use the terminal symbol, that is a start, and after that for reading we will use the symbol, rhombus symbol, and then the processing symbol we will use it, and after that in the processing we will calculate the total and we will print the output, and we will use the terminal to stop the flowchart. Whenever we want to do the decision flowchart, so we will use the decision symbol, and every decision symbol decision is going to be evaluated true and false, and depending on that it will take the path, S path and no path, and both are going to what the next line is going to be from here the next execution is going to be started. So if I want to find out the largest among the two numbers, so we will start with the start terminal, then the input the values. If this is greater than this, then we will initialize, if that is the case, we will initialize the max with the value 1, and if it is not that case, the max is going to initialize the value 2, and we will print the maximum value and we will stop. We can have the nested if else also. So the first if the record code is A, if it is true, we will increment the A count. If it is false, we will see record code is B. If it is true, we will increment the B count. If it is false, we will see record C is what the record code is C. Then it is true, then increment. Otherwise, we will increment the error count. All are going to be what the connect to the end terminal. We can also draw the flow chart or the flow graph for the case statement also. So here the case of the variable, and it has the various values, possible values. If it is a value 1, it will execute this statement. If it is value 2, it will execute this statement. So in this way we can also represent the case structure. We can also have the looping flowchart. So what we are doing is, if we are going to first evaluate the condition. If that condition is true, we will process some statement by using the processing symbol. Again control is going to back to the start of the condition. If that condition is true, again it is going to execute the processing statements. If it is the condition is false, then it will take the no path and it will come out of that particular control box. So here we will have one example where we will initialize our, so here processing, here we are going to initialize the counter and the sum to the 0. If there is some data, okay, so that time we will get the grade, increment the counter, add the grade to the sum, and again we will go to the decision box, and again in this way what we will do is we will read the grade, we will increment the count and accumulate the sum of the grades. So if the no data is there, no more data is there, we will calculate the average and we will display the average, and after that we will use the end terminal. So this is a practice question. You can take this problem statement and you can write the pseudocode for this problem statement as well as the flowchart for this particular problem statement. So this is all about the tools that we can use for writing the algorithm. So we have seen we have used the two tools, or we have learned the two tools that we can use for writing the algorithm. The first tool we have seen the pseudocode, so where we are using some English-like language with some programming construct. So mixture of the both we are using, and the second one is what the flowchart, which is a graphical representation. Thank you.